Today we will discuss about the convolutional codes. So in channel coding in digital communications, one of the code, convolutional code for error correction and detection. So while receiving the code word, whether it is correct or not, the code word which is generated by channel coding technique, which is one of the convolutional code. So earlier, linear block code and cyclic code were discussed. These are all block codes. This convolutional code is different from the block code. In block code, the k number of message bits are transmitted as a block. By adding n minus k parity bits, okay, the n bit, the code word is generated. But in convolutional code, we send the message bits sequentially. So there is a shift register, and these message bits are shifted sequentially using flip-flops. There are the n number of flip-flops or m number of flip-flops in a shift registers. Okay. So the encoder, which is having the convolutional outputs, there are n number of outputs are considered. In this example, for example, 2 stage shift register, that is what the two flip-flops are taken. The m stage shift register m equal to 2. M equal to 2. So this m equal to 2. So the L number of bits are taken as an input, and this sequence is given sequentially, and the nodes S0, S1, S2, for every shift on flip-flop S0 to S1, S1 to S2, the input is transmitted. So the two outputs, path 1 and path 2, there are two outputs taken in this example, and these the generator polynomial is considered by combining these nodes, which are S0, S1, S2, as one of the combination. And in the second combination, the generator polynomial S0 and S2 taken as another combination. Similarly, you can also take another combination S1 and S2 likewise. Okay, here the two outputs are taken, and this is first stage 1, and the next stage the next shift, the polynomial is taken as a power of d, and this d and d square. And the code rate in this example, you can take encoder L number of bits, message bits, divided by total number of code length, n into L plus m. N into L plus m, L number of bits are taken, m number of shifts are required to transmit first bit here S0 to S2. So L plus m, there are two outputs n equal to 1, 2. So this is two outputs, n into L plus m. This is the code length. So here the code rate is taken as 1 by n by simplifying this. So as L greater than, very greater than m, so this becomes n into L into 1 plus m by L. So this is negligible. This is 1 by n. This is the code rate 1 by n bits per symbol. And the constraint length can be taken m plus 1 shifts. So here in this same example, we take the generator polynomial considered to be g of d. So for ith path, so there are number of paths. Here two paths are taken, path 1 and path 2. Okay. And g ith of d, the d is the power of d is every shift, d square, d cube, d power m. There are for every one shift, the power of d is considered in this polynomial. So ith path gi of d taken. Here two paths, g1 of d, I equal to 1, I equal to 2, g2 of d. So the combination of S0, S1, S2 taken 1, 1, 1 combination, 1, 1, 1 combination. Okay. So S0, S1, S2. So the polynomial is 1 plus d square. So the second path is combination S0, S2, 1, 0, 1. So 1, 0, 1, 1, 0, 1 combination. So similarly, if you take S1, S2 combination 0, 1, 1, like that. So this is 1 plus 101, 1 plus d square. D plus d square, d is 0, here 1 plus d square. These are the generator polynomials. So the impulse response taken as 111 in the first path, 101 is the second path. So this example, we generate the code word in a convolutional coding using this encoder. The path 1 taken G1 of D, path 2 is taken G2 of D. And now let us take an example of message bit of 5-bit message, M equal to 5. This is L equal to 5 bits. So the message polynomial is M of D. M of D, 1 plus D square plus D cube plus D power 4. So D plus D square is zeros. So this is what 1 plus D cube plus D4, D power 4. This is the message polynomial. And now the code output in path 1 can be generated by multiplying message polynomial M of D into and G1 of D generator polynomial. So this is message polynomial 1 plus D cube plus D power 4 into generator polynomial of path 1, 1 plus D square. You multiply all the this multiplication of these two equations, we get 1 plus D square plus D cube plus D power 6. After cancelling all in modulo 2 additions, that is what the modulo 2 additions. So assuming if in this multiplication, the D plus D, if at all you get, cancel out, D plus D 0. And similarly, D square plus D square equal to 0, the modulo additions. So likewise, after cancelling all the duplicate parameters, we get the code output is like this. We can write the code output. See, 1 plus D square, 1 and D, 1 D square, 1 D cube, 1 D power 4, 0, D power 5, 0, D power 6, 1. So this is what the code output. And second path output, code C2 of D, is again M of D into C2 of D, message and generator polynomial multiplication. Generator polynomial, second path is taken 1 plus D square. So the message polynomial is this, and multiply a similar, the simplification after simplification, you will get this equation 1 plus D square plus D cube plus D power 4 plus D power 5 plus D power 6. Then the code output binary data can be taken, written as 1 D0, D square 1, D cube 1, D power 4 1, D power 5 1, D power 6 1. So this is what code output. The combining multiplexing of these two outputs as a single output. So this is what single output by combining C1 and C2. This is C1 of D, and this is C2 of D. Combining 1-1 combination 1-1. Okay. So this is what 1-1 of a first bit combination. Whenever message first bit is given, so the output is generated 1-1. Message second bit is given, the output is generated 1-0. And message third bit is given, the output is generated 1-1, and so on. It is given 1-1 and 0-1 and 0-1 and 1-1. This is the code output. So the code output is, the code length is L plus M into number of outputs. So this is what 2 into 5 bits plus 2 stage register, shift register. So 2 shifts. So 2 into 7, 14 bits. 2 into 7, 14 bits is the code length. This is the code output of convolutional code. The same thing can also be generated using tabular form as impulse response G1 of D 1 plus D square taken as sum of S0, S1, S2, the combination. And generator polynomial second output is C2 combination of S0 and S2, 1 plus D square 101. So this is S0 plus S2. For a given 1011 message, 101 10011. So this is the message. And there are two more shifts required as two flip-flops, two stage shift register taken. As last bit given here as at node S0, that will be shifted for once to get to reach S1, and second one more shift is given to reach S2. So that is what two more shifts required. And now initially the shift register initially taken 000, and now so here the first bit one given this MSB, first bit given MSB, and now this is given one shifted, and next shift and next shift. S0 shifted to S1, S1 is shifted to S2. So now the combination of C1, S0, S1, S2. So 1 plus 0 plus 0, 1. Combination of S0 and S2, 1 plus 0, 1, C2. Similarly, second bit 1 is given, 0 is given here, and S0 shifted and S1 is shifted. And now combination of 0, 1 plus 0, 1. Combination of 0 plus 0, 0. So this is what C1, C2. So this is what C1, C2. Okay. And the third bit 0, and next shift. Combination 0 plus 0 plus 1, 1, 0 plus 1, 1. Fourth bit 1 shifted and 0 shifted and 0 shifted here. 1 plus 0 plus 0, 1. 1 plus 0, 1. Third, fourth, fifth bit 1 shifted, and this bit is shifted, 0 shifted here. 1 plus 1 plus 0, 0. 1 plus 0, 1. And two more shifts, 0, and this is shifted here, this is shifted here. And 0 plus 1 plus 1, 0. 0 plus 1, 1. And one more shift, 0. This is shifted here, this is shifted here. 0 plus 0 plus 1, 1. 0 plus 1, 1. So this is the code output. So this is what which is generated just now. So this convolutional code can be generated either combination of this generator polynomial S0 plus S1 plus S2 and S0 plus S2 this way in tabular form, or by multiplying message polynomial and the generator polynomial, combining both outputs and which is generated code output. Now, for every one bit of sequence, first bit given, this is the code output, second bit is given, this is the code output, third bit given, this is the code output. Likewise, there are L number of bits are given, the code length go on increasing. So these code polynomial, this code output can also be represented in a shorter way, either in code tree or a tree list diagram, or in flow diagram, or wherever. So this can be represented as first bit is 1 given, this is generated. Second bit 0 is given, this is generated, like that. So this is the code output. We can work it out for the given encoder. Every bit, first bit either 1 or 0, second bit either 1 or 0, third bit either 1 or 0. For all the combinations of message bits can also be calculated, estimated the code output. So all these code outputs can be shown in a diagram of trellis or code tree or whatever it is. So this is the convolutional code output. So this code output, which is very useful in detecting the message output, whether that code output is received correctly or not, and if it is not correct, we can correct that code output, and thereby we can get it back the message word. So that is what the purpose of convolutional code here. Thank you very much.